Okay, so we are wanting to solve the equation 6 times 14 to the n minus 3 is equal to 3. Okay, so anytime we're trying to solve an exponential equation, we want to get this exponential expression by itself first, because we're trying to get to that variable. The variable's in the exponent, so we've got to get that exponential expression by itself. Right now it's being multiplied by 6, so we do the opposite. We need to divide both sides by 6, and y'all can't see that. We need to divide both sides by 6. So 3 over 6 is 1/2. Now, according to what we did yesterday, at this point, we would want to write both sides so that they have the same base. Well, is 14 a power of 2? No, it's divisible by 2, but it is not a power of 2. So we cannot write these, both sides of this equation so that it has the same base. So in comes logarithms. We need to write this expression in logarithmic form. So log base 14, it's always the base of the exponential, of 1/2 is equal to n minus 5. So I'm changing the form. I'm going from exponential to logarithmic form here, because when I do that, it removes my variable from that exponent, and now it's free over here, so to speak, so that I can finally completely isolate it. I can get it by itself. I cannot isolate it while it's in that exponent. I gotta take it out of the exponent. The only way to do that is put it in log form. Now, when you go from exponential to log form, I always do a very quick check, kind of like when I factor something. I multiply it out real quick to make sure that I factored it correctly. I'm going to do my swoop right here to make sure that I put it in log form correctly. 14 exponents n over 5 is equal to 1/2. That's what I had in the previous step, so I'm good. We're going to leave it like that and solve completely for n. So in this case, we're subtracting 5, so we need to add 5 to both sides. Now, kind of like if it were a square root or if it were a set of parentheses, we do not ever change that 1/2 right there. We do not ever change that number that's inside the logarithm. You don't add anything to it. You do not subtract anything from it. You don't multiply. You don't divide. Once it's in the log, it's stuck in the log. Unless next week we'll talk about a few properties so that we can change that. But for right now, that number never changes. Now, on an answer key, you're not going to see those parentheses right there. But I put them there because you need them when you put them when you put that number into the calculator. Okay? So this is what we call our exact answer, and that's what I'm going to expect to see on a quiz. I want to see the exact answer in log form. Okay? But we always want to check our solutions, so that means that we need a decimal form of that so that we can plug it in. So we need to use our change of base. So that would be the log of 1/2 divided by the log of the base, 14, plus 5. And I'm just writing it out exactly how I'm going to type it into the calculator. I suggest that you write that down too so that you know where it came from when you look back at your notes. So the log button is right there beside the 7. Make sure that you close your parentheses after the 1/2 before the division symbol. Divided by the log of 14, close your parentheses again. Parentheses really, really, really matter here. And then plus 5, I'm going to go ahead and store that as x. Okay, store that as x. So I'm going to put n is approximately, I am going to write it down on my paper, because sometimes they do the answer choices, if it's multiple choice, the answer choices are in decimal form, not in exact form, but I want to see the exact answer. I'm going to store it as x, and then I'm going to go back to my original problem, and I'm going to plug it in, making sure that I put parentheses around that x minus 5, and that should give me 3. Now, if you don't store it as x, let me just show you, if you were to just use the 3 decimal places that I wrote down, if you just plug in rounding it to 3 places after the decimal, it's not going to give you exactly 3. It's going to give you something really, really close to 3. So really, I think it's easier to just store it as x. If you've got to get that decimal value anyway, store it as x, and then you don't have to worry about typing all that in again and the approximation there. Okay, so that's the exact answer. This is the approximate answer. You need to know both. Okay, you need to know both. Because the exact answer is going to be what I'm expecting to see. The approximate answer, you need that to be able to check. Okay, let's do another one. We've got base 10 this time. 10 to the negative 2v minus 5 minus 4 is equal to 66. So again, trying to isolate the variable, solving for the variable. It's stuck in the exponent, so we've got to get that exponential expression by itself first. This time we're subtracting 4. So we're going to start by moving that 4 to the other side. This time it's addition. The first time it was division. This time we're adding. So it just depends on how the initial problem looks as to what your initial first step is going to be. I can't give you an explicit rule on that. You just got to do whatever you need to do to get that exponential expression by itself. So we've got 10 to the negative 2v minus 5 is equal to 70. Please, please, please do not divide by 10. Okay, we are not multiplying by 10. 10 is our base. So we have to put it in log form. Now, I don't have to write the 10. If you want to write the 10, go for it, but it's base 10, so that's the common log. I really don't need a base there. So taking that from exponential form to log form is log of 70 is equal to negative 2v minus 5. And then once again, we're just getting our variable by itself. So we add 5. Again, you never, ever, ever change that number. Once it's in the log, it does not change. I would go ahead and put parentheses around it. The plus 5 just gets tacked on to the end. And then we need to divide by negative 2. Divide that entire side by negative 2. Now, here's a little detail, and we've talked about this a little bit before. We do not leave negatives with our coefficients in the denominator. So on the answer key, or as a multiple choice answer choice, that negative is going to be moved to the numerator. And I expect you to do that as well. I expect you to move that negative to the numerator, apply it to any terms in the numerator. So the log becomes negative, the 5 becomes negative. The 70 never changes, ever. So that's our exact answer. If we want to find our approximate answer, we do need a set of parentheses here because that entire expression needs to be divided by 2. So we'll put that into the calculator, or you can type in the numerator, enter, divide by 2, or if you want to do it all at one time, you need parentheses around it. So there's our approximate answer. I've stored as x. Negative 3.423. Now, your answers can be negative. It's just you cannot take the log of a negative number. So don't throw out any negative answers. Okay, they're not wrong. It's just you can't take the log of a negative number. Okay, and when we plug it back in, we get 66. So exact, approximate.